Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Halim and my matrix number is DN200055. So for today I'm going to present about project 2 for Mathematics for Engineering Technology 2. Okay, so for the first question, the general equation of the mass spring system is m d squared over dt2 plus b dx over dx plus dx equals to f. And a spring is stretched 0.3 m when 5 kg of iron ball is attached. The weight is then pulled down an additional 0.2 m and released with an outward velocity of 2.5 meter per second. And from this question, you want to find the equation of for position of the spring when it is under undamped free vibration. So when under undamped free vibration, we know that B is equal to 0 and F is equal to 0. Okay, so from the question, we know that the equation mass spring system where md2 over dt2 plus b dx over dx plus kx equal to F. And we get the information where the spring stretch is 0.3 m and the mass is 5 kg and the weight we can get by multiply 5 and 9.8. Okay, so and the pull down, we know that 0.2, the upward velocity is negative 2.5. Okay, so we also can get the k by using the formula, and we know that 5, we can use 5 times with 9.8 divided by 0.3 by the spring stretch, and we will get the answer for k, and k is 490 over 3. Okay, so the next step, which is we know that the undamped free vibration is b equals to 0 and f equals to 0, and we can use this equation, and we apply the equation. Okay, so we get the from the equation we get that m is equals to plus minus square root negative 490 over 15i. Okay, so for the next step, we get the equation where x t equals to c1 cos square root 490 over 15 t plus c2 sine square root 490 over 15t. Okay, so from this equation, we just substitute the value of 0, so we get that the answer for C1 is 0.2. And next, we apply the from the previous slide, we apply the formula, and we substitute the value of 0, and we get that we substitute the value of 0, and the equation is negative 2.5 is equals to negative square root 490 over 15 c1 sine square root 490 over 15 0 plus square root 490 over 15 c2 cos square root 490 over 15 0. And we know that the answer for C2 is negative 0.438. So we can get the answer by add the value of C1 and C2. So XT is equals to 0.2 cos square root 490 over 15t plus negative minus 0.438 sine square root 490 over 15t. And we also can write like this. The square root 490 is over 15 is equal to 5.71, and it seems with square root 915 over 5 also equals to 5.709. So for the second question, where if a mass spring system with an iron ball of weight 98 net tonnage can be regarded as undamped free vibration, and the spring is such that the ball stretch in 1.09 meter, And how many cycle per minute will the system execute? What will its motion be if we pull the ball down from rest by the 0.16 meter and let it start with zero initial velocity? Okay, so the information we can get from the question where the ball stretch is 1.09 meter and the mass is 98 ton, and 0.16 is the when the ball is pulled down from by the rest, and the initials is zero, initial velocity, and the weight is 98. So to get the weight is uh, we can multiply 9.8 times with 9.8 times with times 10 power of 3 Newton. And for the speed constant, we can get by apply the formula, uh, and we just substitute the value 9.8 times 9.8 times 10th power of 3 and divide by 1.09, and we get the answer 881.10. And for the time periods of oscillation where is executed by oscillation spring, is the formula is T is equals to 2 pi square root mk, where we can just add the value in the formula. So 2 pi is 2 pi square root 9.8 times 10 power of 3 times 1.09 divided by 9.8 times 9.8 10 power of 3, and we get that 2 pi is equals to 1.09 divided by 9.8 seconds, and we know that the time period is 2.09 seconds. So for the frequency, we can get by using the formula F equals to 1 over T, where 1 is divided by 2.09, and we get the answer is 0.478. And so we know that in 2.09 seconds, only one oscillation complete, and in 60 seconds, we can get by 60 divided by 2.09, and the answer is 28.7 Newton. So um, it complete around 28 oscillation, and 28 cycles per minute the pendulum execute. So from the mean position, the ball is stretched to a distance 0.16 meter, and at this point the velocity is zero. So that that's the extreme point, and we can conclude that the ball will execute about its mean position and its amplitude is 0.16 meter. So that's all from me for project 2. Thank you, and assalamualaikum warahmatullahi wabarakatuh.